Okay, this is the presentation of The Princess Bride by Amy Brown.
And Brittany Knudsen.
The Princess Bride game is Princess Buttercup has been kidnapped. The player acts as the Dread Pirate in order to rescue her. The player must successfully pass through challenges of luck, calculation, and logic.
So there are things like fun things like rock, paper, scissors, to beat Fezzik, or to do like math equations for Rossini, or use items in the swamp. So lots of fun things. Mhm.
Okay, the first step for making our game, we went through um, each of our end user stories and separated them out into layers that we needed to store information. So we broke it down into smaller chunks so that we could work, making it easier to code, working on one small part. And this diagram helps to explain what things relate to and how they relate to each other to make coding easier.
Yeah, it helps a lot breaking it down into layers like this because, we work on kind of like one specific thing at a time. So, like with the model layer, we kind of just focused on setting the foundation for our program and writing down, like here in the diagram, like writing down which attributes we'd need for our program. So it kind of helped us map it all out from the start.
The next step was adding the control layer. These are the classes that hold functions that perform the calculations. So we went through and figured out which classes on the model layer needed calculations to be performed and added a control class for them.
Mhm. And later, we will be going through and adding view classes. So that will kind of keep track of the interaction between the program and the player. That'll be what takes their input and what gives them like the dialogue and everything.
Uh, on this diagram, the numbers and the lines here show the relationships between each class. So, for example, the inventory class here has a line that connects it to the game class by association. Each game has one inventory, but an inventory can belong to many games. And this diamond relationship here shows that it contains the item class. So the inventory class acts as like a warehouse that stores the information from the item class.
And just like yeah, and so just like with that, like if you go to scissors class, like so you can see there's a little this means many. The rock paper scissors class can have many location classes, but the location class can only have one rock paper scissors class. And so this is an association, and like we said also that with this diamond thing, it means that it contains a class. So the map class contains a location class. And these right here, these are all the attributes, and these are the functions of our classes. And this means the little minus means it's private, and the little positive means that it is public. hmm So, should we move on to the NetBeans?
Yeah, so the next step was to take the information that we put on our UML diagram and incorporate it into Java. So we took our Java class and we needed to turn it into a Java bean. We did this by taking the Java class and putting it into NetBeans, where we typed in the name of the class, and then we had to choose whether the class was private or public. Turning it into a Java bean is what this implement serializable was, and then we used code that is already part of NetBeans by going up to source and inserting code, where we inserted a constructor and also getters and setters for each of the attributes that we had in that class.
Yeah, and we did that with all of our methods right here. You can see one of them was the location class, or sorry, with all of our classes over here. One of them was the location class, and just like with the other one, so we had just a regular Java class, and we made it a NetBeans, or we made it a Java bean by importing this this right here. So we could implement serializable, and we made so the attributes, they're all private, and they can only be accessed by by getters and setters. And just like Amy said, something that makes it a Java bean is that we have a constructor class that doesn't have any arguments. You can see that right here.
Okay, and part of this public and private setters also help to show the scope, what the variable scope is. So if we, like in this inventory class, we had a getter and setter that describes description, and when we call the function description from
right here
within the inventory class, we can pass a parameter, you have no items, because this is specific only to the class of inventory. And then we can have a set description in a different class, in this case in an Inigo class, where we can pass a different parameter, and we're able to do that because the scope of the variable is within its class only.
Yeah, and so that that works. We have lots of different description attributes, and we have two kind of location classes. And these really similar attributes. We have in the location, we've got rows and columns and visited and blocked. And in the swamp location, we also have rows and columns. So when we go to because the scope of this value is only within class location, you can have a different value called row in a different location, and they aren't related at all because they're within the scope. And so we implement, if we're in the location class right here, we can pass things into, or we can pass parameters in these functions. So if we go find the location, so here we call the methods for the class location, and with all of these, we're passing some parameters into the location class right here. And so, that's how we pass parameters by calling a function.
Okay. Let's see.
So now I think we'll just go through our control, because we both made some control or some classes for the control layer. So let's see.
Okay, so one of the control classes that I created was for one of our games. It's called Immunity Control, and here we can explain some of the different primitive data types that we used. We used a lot of strings when we made our inventory, our model layer classes. We used strings, but here in the control class, where it's primarily for calculating functions, I used Boolean for this example, and I also used double, and then here within the calculations, we use different operators. So if the weight is greater than 500, or if the weight is less than 50, then the program's going to return a false statement. And here we have the math equation where we're going to take the double shows that the required months it's going to accept decimals, and it's going to take the weight that will be passed in as a parameter when we call the function in our main program, and it's going to take the weight and multiply it by the Poisson constant, which is declared here, and run it through the program to determine whether or not you can pass this level of the game. So I next created a control test in NetBeans to show whether or not the calculations were inputted correctly. And here I was able to I can change the parameters to be test for whatever situation that I think it will. So I can put in the parameters here and change them. Then here I'll explain what I expect to get as the answer, which I expect this answer will be true. And then because I've already created the test control, I come over here and run a test file. And here it tells me 100% the test passed, the output also shows that the build was successful. The test ran without a failure. So there we go.
Yeah, awesome. So yeah, I created also created a control class. I called it Help Fezik, control, because the purpose of this is to help Fezik. He has to take on a group of thieves, and he asks you to see how many there are. So and I made this a double just in case somebody wanted to be funny and put in a decimal. I didn't want that to break. So this is a double, and then he's going to take him down with rocks. And so this is the number of trips he needs to take the rocks over, so he can beat the thieves. Yeah, so here is it's a double, so it can be a decimal. I check to make sure it's valid, because the requirement was that the thieves be greater than 15 or 15 or greater. So I checked that with this less than operator. And then I check right here if the input was or if yeah, I check right here if the rocks needed, which I have right here calculated as half the thieves that are there. I check here if that's a decimal. So if it is a decimal, then I just add another rock because they need another rock. No matter if it's 0.5 of a person, I'm just gonna count it like that. And then so I have doubles and ints mostly with this one. And so I have yeah, and so this is just to double check if the trips needed, if the user inputs. All right, so there are 20 guys out there and you need to make 3 trips, so it checks if the input of the player, which was the num trips, is actually the correct number of trips that Fezzik needs to take. And then it returns the result right here. So we're going to test it and make sure that we did that right. The control test is right here. And as you can see, there's some different test cases. And so this one is to test the decimals. And so I made that with a decimal input, and the user gets 21 trips, which goes down here. And it goes to the code and compares if the 21 trips is correct. Yeah, if they got it right. So it compares their answer with the right answer. So we test that and see how that goes. So great. It was 100%. You can see that it went through all the test cases. Yeah, of the different possibilities. So yay! So we'll just keep working on that. So I think that's it, right?
Yeah, so that's the presentation of what we have learned so far in building our game.
Awesome. Thanks for watching.